We place our kettle on a hot stove and we wonder how exactly is the heat transferred from the hot flames into the body of the kettle. To answer that question, we have to look at the atomic mechanism of heat transfer. To do that, let's take a look at a cold object. So we have a cold object here and we zoom into it. What we find out is that it's made up of atoms, lots of atoms, all of which are vibrating. However, these vibrations are very weak. They don't have much energy in them. The vibrations are weak and the object is cold. On the other hand, if we look at a hot object and we zoom into the structure of a hot object, we'll find out that it's also made up of atoms, but these atoms are vibrating much more vigorously. There's lots of energy in the atoms. We have a question that what would happen if we place a hot object next to a cold object such that they are in contact. The atoms of the hot object will collide with the atoms of the cold object. It's exactly the same what happens in a game of pool. In a game of pool, a ball comes on and strikes a ball which is at rest. The ball which was moving has more energy than the ball which was at rest. In this entire collision, energy is transferred. Energy is transferred from the more energetic object into the less energetic object. That's exactly what will happen if we place a hot object next to a cold object. The atoms will collide and they'll transmit energy. Energy will flow from the hot object into the cold object. This process will keep on going until we reach thermal equilibrium, which is just a fancy name that both objects have the same temperature. Before we move on, let's take another example. Suppose we have a metallic spoon and we heat one of its ends. We know that the entire spoon will quickly become hot. Heat will be quickly transmitted throughout the length of the spoon, and the entire spoon will become hot. This is an example of a good conductor, a material which quickly transmits heat. You heat one of its ends and the entire object becomes hot. The heat is quickly transmitted. Compare this with a wooden spoon. We take a wooden spoon and we heat one of its ends. It will take much longer for the handle of the spoon to become hot. So this is an example of a bad conductor. But the question arises, what makes an object a good conductor or a bad conductor? The answer to that questions are free electrons, also known as valence electrons. They are responsible for a material to be a good or a bad conductor. Let's try and understand what free electrons are. Here we are looking at a material which is a good conductor. Let's heat one of its ends up. When we heat one of its ends, the electrons present, they gain energy and they are free to move throughout the structure. They transmit heat readily from the site of heating it up to the other parts of the body. So these free electrons are free to move, and a good conductor has lots of free electrons. On the other hand, a bad conductor or an insulator does not have free electrons. So if you heat them up, the only way heat can transfer from one location to the other location is due to atomic collisions. No electrons are involved. So that's what makes an object a good conductor or a bad conductor. Some examples of good conductors are gold, silver, and steel. And examples of bad conductors include wood, wool, etc. Now we can summarize this entire discussion we had so far. That is how heat is transferred from a hot object to a cold object. The answer is, it's due to the collisions between atoms, molecules, or electrons. This entire process is known as conduction. So that's it. That is the process we were after. Returning to the example from where we started, We can now explain how the hot flames transfer the energy into the body of the kettle. The process is conduction. I hope you found this video helpful. I'll see you in the next one. Take care. Bye-bye.